Hello and welcome to Wednesday's video. Today we're going to talk about graphing linear inequalities. Okay? Very much like graphing lines, with the exception of we will be adding in multiple solutions now. When you graph a line, that line are the only solutions to that equation. In an inequality, we need a whole bunch of solutions. Okay? So we'll talk about that here as we go forward. Okay? So let's dive right into it. We're going to treat it like a line, okay? But it's going to look like, some examples, if you will, of it are going to look like y equals negative 1/4. Oops, that breaks, not equals. Y is less than negative 1/4 x plus 7, or 3x plus 2y is greater than or equal to 14, would be some examples of linear inequalities. So the steps that we go about in order to solve them, there's really only two steps. The first step is we're going to think about it like it was a line. Okay? So we're going to not worry about the inequality. We're going to solve for y, because then we can graph our y-intercept of b, and we can we can plot some more points using the slope as rise over run. The difference here in step number 1 is that if we are in a less than or equal to or greater than or equal to case, our line is going to stay solid. If we are in a less than or greater than case, then our line will need to be dashed as we go through and do that. Okay? So we're going to put our line on either solid or dashed, and then what's going to happen is now we are going to have to shade one side of that line. And that shaded area is going to make our inequality be true on all of those shaded points. I like the test point method. Okay? It's not that difficult. We can pick up any point we want as long as that point is not on the line, plug it back into our original inequality, and decide the truthiness of that point. Okay? So let's do an example here first of that truthiness of that point. So I am going to take the point 0, 0. The origin is a phenomenal point to use as your test point. I recommend it as your test point as long as your line doesn't go through the origin. You can use it. Okay? So I'm going to put in 0 for y. And here, 0 for x. And then I just simply do that math. 2 times 0 is 0. 0 plus 4 is 4. So I get here 0 is less than or equal to 4. And that, ladies and gentlemen, is a true statement. 4 is bigger than 0. So that's true. So then 0, 0, the origin, is a solution. Okay. Now, let's try another one. Let's try negative 2, 10. Again, in the same inequality. Y is 10, less than or equal to 2 times negative 2 plus 4. Negative 2 times positive 2 is negative 4, plus 4 is 0, so I get 10 is less than or equal to 0, and that is a false statement. 10 is actually bigger than 0, it's not smaller than 0. So, therefore, negative 2 comma 10 is not a solution. So quick test points for us to do. All right, let's dive into two examples here. Let's graph these two lines. First off, this line is already in y equals mx plus b form for us. So then I can say that this number is my y-intercept, which is 0, comma, negative 3. So I'm going to go down 3 from the origin, and I'm going to put my dot right there. This number right here, the coefficient on the x, that is my slope. So from my green dot, I'm going to rise negative 1, which is down 1, and I'm going to run 2 to the right. So down 1 to the right, down 1 to the right, down 1 to the right, and down 1 to the right. Or I could go up 1 and 2 to the left. And I'd be there. Okay? This is telling me that I have a solid line. So I am going to fill in that with a solid line. One that I want. And there is my solid line. Love every part of it so far. Okay? Now I need to find a test point to try. I didn't go through the origin, so I'm going to use that as my test point. Okay? If when I plug it in it's true, I'm going to shade on the side of my test point. If when I plug it in it's false, I'm going to shade on the other side of my test point. Well, I get 0 greater than or equal to negative 1/2 times 0 is 0 minus 3. So I get 0 is greater than or equal to negative 3, and that is a true statement. So I am going to shade on the test point side of my, come on now, maybe it won't let me because my viewer is in the way. Now I'm going to move over even more. It's this one. And then this one. Oh, there it is. Now it's in there. There it is. There it is. And big. And wait. So when I shade that entire side. Right? Not just a little part of it. I shade the entire thing. Hopefully then I'll get rid of that thickness of my line here momentarily. Anything out. Go. Love it. And then we can say, oh yeah, any point in that range will make it be a true statement. Move this back over here. Okay. Next one. First off, I'm going to get it into y equals mx plus b form. So the first thing that I am going to do is I'm going to subtract 2x from both sides. That's going to give me negative 3y is greater than negative 2x plus 12. Then I'm going to divide every term by negative 3. That's going to give me y is less than because I'm dividing by a negative, that rule of flipping the absolute value still holds. 2/3, -2 divided by -3 is +2/3. X, +12 divided by -3 is -4. So this now tells me that my y-intercept is 0, -4, 2, 3, and 4. This now tells me that I have a slope of 2/3. So I'm going to go up 2 and right 3, up 2 and right 3, up 2 and right 3, or down 2 and left 3, down 2 and left 3, down 2 and left 3. This is telling me right here that I have a dashed line. Okay. Always want to check that dashedness before you draw your line, because it needs to be a dash, and so not solid. So when you draw it in, you get to draw it right. You don't have to go back and erase. Okay. Test point then. I again can try the origin. I don't have to always try the origin, but the origin is the easiest one to try because both x and y terms go away. So 2 times 0 is 0, minus 3 times 0 is 0, and I get 0 then is greater than 12. And that is a false statement. So I am going to shade on the opposite side as my test point. Let's use stars this time. So this one would have this side shaded. Okay. And that, ladies and gentlemen, is how you graph linear inequalities. You can continue on with the worksheet for this week. There's a couple of questions in regards to